All right, what 37 is asking for is it's saying that there's an angle of repose that each type of material has that when it's kind of piled up, it forms a cone. And the cone has a particular angle or again, the cone that's formed winds up being symmetric. Right? And so it's an isosceles triangle if you look at it from the side. And the angle that's formed on the base of this isosceles triangle is the angle of repose. Okay, so what they're asking you or telling you is with salt, when they store it, the pile that stands 11 feet tall has a total diameter, so the whole length of that pile is going to be 34 feet. And they asked you what would this angle here be? Right? And so in looking at that, what we can do is use some properties from geometry. When we draw in the altitude of an isosceles triangle, it's going to do what to the base? Cuts it in half, right? Bisects it. So what's this leg of the right triangle in green outline going to be? Half of 34, so 17. And so now if you use this green right triangle, you can find the angle that we're looking for by relating the trig ratio that identifies the relationship between an angle, a side opposite that angle, and a side adjacent to that angle. So opposite and adjacent relates which trig ratio? TOA, or tan. So we know that the tangent of theta is equal to opposite 11 over adjacent 17. And now we can use the inverse trig ratios to solve this. We're solving for an unknown angle, so we take the inverse trig ratio, so inverse tan of the ratio they gave us, 11 over 17, and that's going to identify what our angle measure is. So if we take green diamond T for inverse tan, 11 divided by 17, I'll put a decimal in there so my answer is displayed as a decimal, and I get my measure to be 32.9 degrees. Okay, do make sure you're in degree mode, okay, since we're finding our angle in terms of that. All right. Did I ask you about the other problem too, with the 15-foot height? Yeah. So you guys would understand how to set that up too, yes? Okay. So if you looked at this, you would assume that the angle is going to stay the same. So really, I mean, if we extended this to a height of 15, the angle would still be the same angle, right? Because it's just kind of gravity. It's what's created when that pile is formed. And so here, what we would be looking for is this measure, the adjacent side. We would know the given angle, so we'd still use this same tangent ratio. The tangent of 32.9 degrees is equal to opposite 15 over adjacent. We'll call this x. And we can now solve for x. So we'll just use the calculator here and the solve feature. So F2, algebra tab, solve, type in, here we know what our angle is, so we take the tangent of that angle. Okay. Now, we'll set that equal to 15 over x, and we solve for x, and we hit enter, we get our solution of 23.18. And now, we could have thought of this a different way too, right? Because looking at this equation, what is the tangent of 32.9? The tangent of 32.9 theta is, we actually have the exact value of it, right? The tangent of 32.9 is this ratio right here, 11 to 17. So we could have just said 11 over 17 is equal to 15 over x. Now, does that make sense? Again, going back to what you guys did in geometry maybe when you talked about similar figures. Okay, so are these two triangles the same, or similar triangles, the green and then this purple one that I drew here? Yeah, they have two angles that are the same, a similarity. Therefore, the ratio of their corresponding parts is the same. So 11 is to 17 as 15 is to x. So you could have just gone directly with that ratio and solved. If we solve this ratio here for x, so if we took 11 divided by 17, if we solved the equation, 11 over 17 is equal to 15 over x, and we solve for x, in decimal form, we get the same thing, 23.18. Okay, this gives you the length of x. The problem itself specifically is asking for the diameter. So if you double this measure, so we'll take this times 2, and that's going to give you the diameter. So if we take 23.18, multiply that by 2, you would get your 46.36.